Welcome to the Standing Waves on a String Lab. In this experiment, we'll be measuring the linear mass densities of a string using the frequencies of its standing waves and comparing it to the directly measured value.
First, ensure the scale is calibrated and that it points to 0 when nothing is on it.
To determine the mass of the mass holder, place it on the triple beam balance pan. We know the mass holder weighs approximately 50 grams, so we only have to play with the last slider. Once you have it around 50 grams, you might have to adjust the finer slider to get it right on. As you can see, this is really close to balanced.
Set the length of the string between the mechanical vibrator and the bridge to 1 meter to start with. You'll also need to add 100 grams to the mass holder and hang that on the end of the string. Plug the mechanical vibrator into the function generator's ground and low impedance output. When you first turn on the function generator, it will default to 1000 Hz. You'll need to adjust that, as well as the amplitude. Make sure that the amplitude is at least at 50%, and then start adjusting the frequency downwards by quite a bit. Because of aliasing issues between the camera and the vibrations of the string, it won't look the same in real life as it does on the video. However, you can still see the nodes on the video, and that's the most important thing. Although the manual specifies to begin at n equals 1, I usually find it easier to start at n equals 2 because you can actually see a node in the middle of the string at that point. Once you've found the frequency for n equals 2, you can divide that by 2 to find the frequency for n equals 1. It's much more difficult to see that because there's no node in the middle of the string. From there, move on to the higher frequencies. Here you can see the n equals 3 standing wave, and due to the more similar frequency of the vibration to the camera's frequency, the aliasing effects are stronger. Increase the mass on the hanger to 200 grams and repeat the same process. Do it again for 300, 400, and 500 grams. Next, try varying the length. You should use at least 5 different values between 1 meter and 2 meters. Now it's time to measure the linear mass density of the string directly. Weigh it on the electronic balance, and then measure the length of the string. In exercise 2 of this experiment, you'll be using a thinner string. Start by finding a particular harmonic frequency. You can then vary either the length, or the mass, or the frequency as you did before in order to create a graph.
We hope you enjoyed this video so much you gave us a standing ovation.